Assalamu alaikum. So today I'm going to present my paper uh, for CRC conference. So the title of my paper is Evaluation of Hybrid Deep Learning Models for Anomaly-Based Fraud Detection in Digital Banking. My name is Mohammad Salim. I'm the presenter. And my supervisor for the PhD in cybersecurity, I'm a PhD candidate, is Dr. Hafiza. Dr. Mohammad Kamrul and Mr. Omar Hassan are my co-authors. I'm studying in the Faculty of Information Science and Technology in UKM. So, in this study, the motivation for this study is digital banking fraud causes loss of billions of dollars annually, and hybrid deep learning models are increasingly proposed to catch this. Too many of the published studies evaluate these models using a random trained test splits. And the random split lets future transaction data leak to the training, inflating the reported performance beyond what real deployment would see. So the gap is random split literature reports that the F1 always like related to the accuracy will be 88 to 91%. Then it's not easy to publish a study that test these models under a strict temporal or leakage-free protocol. Contribution. So three hybrid deep learning models in this study evaluated under identical leakage-free temporal conditions. Empirical measurements of the gap between a random split and temporal split results. So we'll have direct quantitative connection between literature claims and experimental confirmation. This is like established compared to the baselines for the future drift aware fraud detection, also research. Methodology. So the data set for that we are using, CCF data set, has 284 around 1,000 transactions. Around 492 of them are fraud cases, and 30 features are there for this data set, including the time, the amount, and many other features. Okay, so the way that we are using in temporal split is using 70 the first 70% for the training, then the other 15 for validation, then the other 15 will be used for the testing. Stored chronologically by transaction time, so do not shuffle or any future leakage will not happen to the training. Smart also oversampling applied only to the training data set. That's it. For validation and testing, okay, to solve the imbalance class distribution, as you can see, which is like the very low percentage of the fraud cases. So oversampling or smart is needed for that. المethod. Three hybrid deep learning models were tested in this study: CNN, LSTM, CNN, GRU, and autoencoder with LSTM. So all of these, and plus two other machine learning also, classical machine learning models were tested. They were getting high also F1 or accuracy in the literature. So also we tested these two in addition. This is like a results, as you can see, after we applied on the CCF data set. Uh, you can see all the F1 and the AUC ROC numbers. Okay, so values, and these are the curves and diagrams. So as you can see, CNN GRU was getting higher accuracy in the F1 in terms of F1 and AUC and ROC. Then for the models, maybe for around the first was getting higher, okay, as a machine learning model. Uh, okay, while logistic regression is much less, and the others also going behind, far behind. All three hybrid deep learning models, as you can see, they are getting recall 0.750. So identifying like almost 39 of the 52 fraud cases in the test data they could detect. Okay, temporal performance gap. So as you can see, this according to the literature, this what we were getting in the one of the top studies for the deep hybrid learning models. Okay, you can see these two studies then using a random. While we can use random split, but we use temporal split, and this is what we get. So we can see this like part of the problem is that they were using a random split, which could be merging the same data could be used for both the training and what else, and to the also validation and testing, which will give you very high accuracy. And to be honest, this is why most of the papers are getting very high accuracy numbers and F1 and other values due to this way, which I can say it's kind of misleading results. If you go and apply temporal, test. So, and the difference is almost in the F1 around 0.23. That's how much performance drops when you start like, no, it's not like only it's cheating, but when you start using a temporal split rather than random. It's kind of, I can say maybe it's kind of misleading or trying to get high values. So that's why. So these are the important references for the study, and what we can like take away. Temporal shift is empirically can be demonstrated, and these are the values that we got. Then all hybrid deep learning models consistently missing the same 13 of the 52 fraud cases, suggesting evolved fraud patterns, absence from the training data. Random forests are strong, showing reflects the CCF data because it's a flat data set. Non-sequential structure has no sequential structure, not a general weakness of deep learning, of course. So the only limitation maybe we were using a single data set, CCF, not like no formal significance testing. A drift can be inferred indirectly rather than directly for the testing and validation, since we couldn't or these models couldn't detect all the fraud cases. Thank you, and I hope it was clear for you. Have a good day, and I wish if I could join on physical, but subhanAllah, I didn't work. Thank you. Goodbye.